Zirconium has an HCP crystal structure and a density of 6.51 gram per cubic centimeter. What is the volume of its unit cell in cubic meters? So its density is given. So we can use the formula for the density, theoretical density, to find the volume of the unit cell. So this is rho. Rho is equal to n times A divided by volume of the unit cell multiplied by the Avogadro's number. So for an HCP structure, n is equal to 6. So number of atoms inside of the unit cell, full atoms. A is the atomic weight, which is 91.22 gram per mole. So this atomic weight can be noted down from the periodic table. So what is the volume of its unit cell? So and Na we already know. So we can input the values. Rho is 6.51 gram per cubic centimeter. Okay. So remember about the units. So we are using the units of in cubic centimeter over here. N is 6, A is 91.22 gram per mole. Okay, so then divided by VC we don't know, we can find from here. Na is 6.022 into 10 to the power 23. So now we can calculate the value of VC. So the value of VC will be 1.396 into 10 to the power minus 22 cubic centimeter. So this is the answer for part A. Well, it is asked that the answer should be in cubic meters, so you can, because we know that 1 centimeter is equal to 10 to the power minus 2 meters. So 10 to the power minus 2 times 3 is minus 6, and minus 22 minus 6 is minus 28. So in cubic meter it will be 1.396 into the 10 to the power minus 28 cubic meter. So this is the answer for part A. Answer for part B. So what is asked? If C over A ratio is 1.593, compute the values of C and A. Okay, remember that in HCP crystal structure, C over A is a parameter in the unit cell. So C is the height, A is the length of the side. So it is given over here is 1.593. Well, for ideal HCP structure, the value of C over A is 1.633. Okay, 1.633, which is in exact term equal to 8 over 3 square root. Okay. Okay, so but anyway we have to use this value over here, 1.593. So what is asked is compute the values of, so we have to find the values of C and A in this case. Okay, so for this we need to know that the volume of the unit cell for HCP is equal to there is a specific relationship for this, which is equal to 6 R square C under root of 3. Okay, so in fact we know the value of VC, but we don't know the value of R in this case, and we don't know the value of C in this case. But it is easy actually, so even because we know that R is equal to A by 2. So if you take this HCP structure, so I did not draw it very well, but anyway, all these 6 sides are of length A, and since there are atoms at these corners, so these atoms are touching with each other, so the radius of each atom is R, so this distance will be equal to 2R. Okay, the radius, this is the radius R for the atoms. Anyway, so we know that R is equal to A by 2. So here we can put R, where we know R in terms of A by 2, and then we know the value of C in terms of A, so everything is now known. So VC is 1.396 10 to the power minus 28 6 R square. R square will become now equal to A square over 4, and C is equal to 1.593 A. 1.593 A, and then it is equal to under root 3. So well, everything is known except A, so calculate A from here. Okay, calculate A from here. So it is 3.23 into 10 to the power minus 10 meter. So in nanometer terms, so we can multiply it with 10 to the power 9. So it will be 3.23 into 10 to the power minus 9. So it will become 10 to the power minus 1 nanometer. So, or in other words, it will be 0.323 nanometer. So this will be the dimension A for the unit cell, and the dimension C for the unit cell will be equal to 1.593 times 0.323. So it is equal to, it will be equal to 0.515 nanometer. So these are the answers.